Chapter 9, testing the difference between two mean, two proportion, two variance. Here we have the words here, two mean, two proportion, two variance. For two mean ni, we will use Z test, we will use T test. Okay, two proportion, proportion lah. Okay, proportion, and variance. Variance more on the chi-square. Chi-square test. If you look at this is an example of the population. We have one population, then we want to check whether the data set, the sample inside the population is different or not. Basically, we have two mean lah. Jadi kita akan ada dua mean, ataupun dua variant, ataupun dua proportion. Jadi kita akan use this chapter 9. Yang hypothesis testing tu, kalau we check again for the hypothesis testing, is more on the one sample sahaja. Okay, for example this one. Researcher wish to test the claim that the starting salary is less than 79,500. Okay, they are regarding for the population punya information, tapi they want to check for some sample here. They want to compare this sample to the population. That's what we learn in hypothesis testing. Tapi untuk yang chapter 9 ni, mana chapter 9? Chapter 9 ni, we have two sample. We have two sample here. Then from these two sample, we want to investigate whether they are similar or not. Okay, whether they are similar or not. If they are similar, then the population mean 1 and mean 2 is no difference, is equal. If this one, they are not similar, they are different, then they are not equal. Okay, there is a significant difference between this sample and this sample of the population. Okay, hypothesis testing, saya ulang balik. Hypothesis testing, we have the population here, then we want to check the sample inside the population, is it different to the population. But here we have two sample. Okay, two sample from maybe from the different population. Okay, maybe from the different population, but then when we check for this different population, it show that they have a no difference between the population. It means similar, that particular population is similar. But for this one, the population, when we check based on the sample or based on the population, it not equal, is different. Then they are significantly different between one population to another population. That what we going to learn in chapter 9. Okay, that is the basic understanding. What is the difference between chapter 8 and chapter 9? Okay, I continue. Okay, this similar. We have the step 1 until step 5. Step 1 until step 5 you need to do. We go directly to the 9.1. This example, you can turn to page 491. A study using two random sample of 35 people. If you still remember, if the number of sample 30 and above, we using a Z test. We using a Z test. This one we will use table E. Okay, we will using table E. A study using two random sample of 35 people found people each found that the average amount of time those in the age group 26 to 35 years spend per week on leisure activity, okay, 39.6. That's mean this is a mean. This is a mean. Those in the age of 46, 55 spend mean 2. This mean 1. Assume that the population standard deviation for those in the first age study 6.3. Second group 5.8. Now we have the standard deviation for 1, standard deviation for 2. At alpha 0.05, can it be concluded there is a significant difference in the average time each group spend on the leisure activity? Okay, first of all, we need to doing step 1, hypothesis. We need to state the hypothesis. What is the hypothesis? For null hypothesis, mean 1 equals to mean 2. Mean 1 not equal to mean 2. Dia tak ada state dekat dalam ni. They have no statement about less or greater. That mean is not equal. Okay, hopefully you understand. And then we go to critical value. Okay, critical value. What we need to do for the critical value, we need to draw the diagram here. Okay, hopefully we have enough space here. Macam tak cukup je kan. Okay, now for the critical value, the alpha is 0.05. But we cannot use alpha 0.05 because we need to divide by 2. Because here we have 2 tail. Okay, we have 2 tail. That means the alpha will be 0.025 here and here. 0.025. We need to find the Z here. Okay, this is a repetition. If you look at the what we call at the middle here, this is the H null, and this part is H1. That's why this at the middle is non-critical region. This one is a critical region. For the left and the right tail. We open to the table E. Okay, table E. How to find the Z value? 1 need to minus with 0.025 equals to 0.975. 975, this one. Then we get 1.96. The Z is 1.96. And also you need to remember there is a negative value here, negative 1.96, and also positive 9.16, because there is a 2 tail. Then we compute the test value. Termasuk nilai lah ya. Jadi mean 1 minus mean 2. What is mean 1? 39.6 minus 35.4 divide. Ni tak ada ni kosong. Square root. We have a standard deviation S1 6.3 square. Here is the variant. What they give you is the standard deviation. Please make sure you understand, yeah. 35, we need to plus 6.3, another one 5.8 square, 35. Similar, right? Is it similar? Yes, similar between both of the groups. Equal, you need to calculate it, compute it using the calculator. $39.6 minus the 35.4, and the below one we have the square root, and also we have fraction here, 6.3 square, and the below we have 35. We need to have plus here, fraction 5.8 squared. At the denominator we have 35, and then 2.9. That is the answer for the test value 2.9. What the okay, I try to find something that easier for us to look at. Maybe this one. Okay, 2.9. 2.9, where is the location of 2.9? Above here. Okay, 2.9. Kalau yang kat sini ni berapa? 1.96. It means that the test value falls at the critical region. Okay, it fall at critical region. We will reject null hypothesis. Okay, we reject null hypothesis. Then you need to do for the step 1, step 4 and step 5. Basically similar to the hypothesis testing previous chapter. And of course you can look at page 491 to confirm it. Okay, macam mana dia tulis. They have all together 5 step here. All together we have 5 step here. And then this one you can try by yourself whether you understand or not for 9.2. 9.2 it will become more difficult. Why? Because you need to find mean 1 and also mean 2 based on the data, the raw data they give to you. Okay, you need to find the mean and also the standard deviation for the both of the male and female. Okay, this for the Z test. If you look at this, in this data set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 5 equals to 50 data set. 50 sample. Okay, when the sample is 50, that means it above than 30. Okay, it above or equal than 30. Dia lebih tinggi daripada 30. That means we need to use Z test. Okay, this one will be 0. Okay, we have no information about the population mean. Hopefully you can do for 9.1 by yourself. And then this one is a repetition on the what you already learned during the confidence interval chapter. Just insert the value inside the formula. Just insert the value inside the formula, then you get the data. But you need to be very careful about the confidence interval. That's confidence interval, we change it to the alpha over 2 equals to 0.05 divided by 2 equals to 0.025. Why this value important? So that we can find the Z alpha over 2 to put it here. The mean 1, mean 2 already there. Variant 1, variant 2 already there. Okay, here. I will not show to you lah. Okay, you just insert the value. It's not really difficult. 9.4. A researcher wish to see if the average weight of newborn male infants are different from average weight of newborn infant. She select a random sample of 10 male infant and find the mean weight is 7 pound 11 ounce. The standard deviation of sample is 8 ounce. She select a random of sample 8 female infant and find the mean weight 7 pound 4 ounce and standard deviation of the sample is 5 ounce. Can it be concluded that alpha 0.05 that the mean weight of male is different from mean weight of female? Assume the variable are normally distributed. Here if we look at this, we have 10 here for the first one untuk male, and then for the female we have 8 here. That means the n value is less than 30. When n value less than 30, we cannot use Z test. We need to use T test. Hopefully you understand lah. Many times I already explained about this one. If you have more 30 or more, we using the Z test. Lesser than 30, we using the T test. However, for this question is quite difficult because of the weight is in the pound and ounce. It's quite difficult because you need to change everything to single unit only. Okay, saya pun tak faham sangat lah. Ni untuk yang weight punya unit. For the overseas ni, dia guna ounce lah, pounds lah. Jadi kita senang saja guna kilogram kan. Tak apalah yang itu. Jadi kalau kamu tengok in textbook page 501, okay, 501, I change to red. Here we have the 7 pound 11 ounce. 7 pound 11 ounce ni equals to, ni for the male, equals to 1 to 3 ounce. Okay, and then for the female equals to 116 ounce. Jadi we base on this lah. Okay, we base on this without having any difficulty for converting it. Jadi please lah ya, make sure that you understand lah. This is the weight, and of course in your test, in your final, we are using unit that in Malaysia we understand lah. Okay, it's similar to the previous Z test. Okay, previous Z test. However, for this one, of course, they have a different formula. That's test value you need to insert using all the data given. Okay, we do one by one. What is the hypothesis here? Do we see any less or greater? No, we do not see any less or greater inside this. Then it will be not equal lah, not equal. For the mean itself, the null hypothesis is mean 1 equals to mean 2, because for this one is giving you the data about the mean, then using the mean lah. Okay, and then we have the mean 1 not equals to mean 2. That is the hypothesis. And then we have the critical value. For this critical value, for step 2, you need to understand, because here we have two different mean, two different number n. N for the male is 10, and for the female is how many? 8. Then what we choose for degree of freedom? Okay, df what we going to choose, because they are different here. We need to choose 10 or 8. The answer will be the smaller one. Okay, the smaller one is 8 minus 1 equals to 7, and the alpha 0.05. Because of this one is t-test and 2 tail, okay, 2 tail, we can directly go to 2 tail here and go for 0.05 without dividing it. That the simplest one lah. Itu yang paling mudah sekali. Kita sebenarnya boleh guna juga one tail, tapi saya risau nanti kamu penin. Okay, dia tak payahlah, kita pergi kepada directly go to 0.05. Here we have the T alpha divided by 2, T alpha divided by 2. Here is the critical region. Here is the critical region. Here is non-critical region, or equals to the null hypothesis lah part. This one is alternative hypothesis. Okay, now we try to find the T value. Okay, 0.057. Here we have 7. 0.05. Jadi we need to underline it. Okay, hopefully I'm not mistaken. 2.365. 2.365 equals to 2.365. 2.365. Missing 6. This one is negative 2.365. Okay, finish for the table. That is the critical value. Then we need to insert the value inside the test t test formula. Okay, we supposed to extract out all the information, yeah. However, doesn't matter lah. And then we have the mean 1 minus mean 2. We have the 123 minus 116 dividing by square root. We need to find the standard deviation. Here it give you standard deviation. When it give you standard deviation, of course you need to square it. Okay, if it give you a variant, do not square it. Jangan kuasa dua variant, ya. Kalau dalam soalan ni dia bagi variant, do not square it. Kalau kamu square it, then you will have a wrong answer. And then we have what? 7. Sorry. For male, 10. Okay, plus we have standard deviation 5 ounce. How many? 8. Then what is the answer? We need to use calculator lah. One, 2, 3 minus 116. At the denominator, square root, we have that 8 square, and then at denominator we have 10. Then we have plus another fraction 5 square, and then denominator we have 8 equals 2.268. Where is 2.268? I enlarge a little bit here. Okay, that's 2.268. It falls on the non-critical region. When it falls on the non-critical region, we fail to reject null hypothesis. Okay, we fail to reject null hypothesis. That is the decision, and then of course we need to summarize the result. Okay, based on page 501. there is not enough evidence to support the claim that the mean of the weight of male infants is different from the mean of the weight of the female infant. It's not really difficult lah, yeah. We have step 1 up until step 5. Similar. What is the different table that we use? Second one is the formula. Then we insert the value inside the formula. The most important part, you know how to determine which test you want to use. Whether it's a Z test, whether it's a T test, whether it's proportion, whether it's a chi-square test. And then we have the confidence interval for 2 mean. For T test, just insert the value. Insert the value. I will not do for you lah, because this one just insertion of the value. Kalau kita nampak, memanglah nampak panjang, complicated. Tak ada lah. It is very simple sebenarnya. We are not here to derive the formula. We are here to use the formula. Okay, now we move to another part of T test. Okay, this one we call as a pair sample T test. Okay, this one is also been called as independent sample T test. Independent sample T test. Here we have paired sample T test. Why we call paired sample T test? Because what happened to the past may be influencing the future, or currently been influencing by the past. That means it have the time frame. Dia ada jangka masa, jangka waktu. Kita buat kita buat uji kaji melibatkan masa lepas dan masa sekarang lah. Okay, kita melibatkan masa lepas dan masa sekarang. If you look at here, of course, if it T test, it must less than 30. Must less than 30. Okay, and here we have the bank 3 years ago and today. This one in the page page 510. Okay, 510. And need to be very careful lah, yeah. You need to be very careful, because this one for the hypothesis is quite interesting. Okay, quite interesting, because you need to do a little bit memorization of what you need to know. Okay, what I always tell a student, if today, okay, today greater, D is less than 0. Okay, and if today less, the mean D is greater than 0. This one you need to memorize lah. Okay, if today greater, D is the symbol. Is today less, then this symbol will change lah. Mean D will greater than 0. Okay, they have a reason behind this, but I will not explain about the reason, because if I'm going to explain about the reason, then I need to explain about the formula itself. Okay, why the formula is like that, so that we can have our claim like that. It will be a long lecture lah. Okay, what the easiest way to understand or doing it correctly, just remember this today greater, then the symbol is like this. This one just 1 marks. Okay, the highest marks can be given is 2 marks. It will not exceed that. Don't burden yourself with something that not really that important. Okay, you remember as little as like this, then you can write it correctly. Okay, today greater, the mean D is less than 0. Is today less, then they will greater than 0. Okay, fine. Already explained that. Now we move to the first question regarding this pair sample t-test. Of course lah, you can read everything. Okay, now we go to the here we have the bank. The deposit bank is greater today greater than 3 years ago. Jadi today is greater for this one. Then we need to make a statement about the hypothesis. For this one, we use mean D, okay, equals to 0. Then for the alternative hypothesis, lesser than 0. That's how you write the hypothesis. What can make this BIO610 disaster for you if you do not know when to use this pair sample t-test? Maybe it seems like a t-test, a normal t-test, then it's very wrong for you lah. If this question give about 7 to 8 marks, then you will lose everything. Okay, you will lose everything. That's why you need to be very careful if it regarding to the t-test, because sometimes t-test you are confusing between pair sample t-test and independent sample t-test. Pair sample t-test involve time frame. They have a before and after. Okay, they have what happened to the past, what happened currently. Okay, what happened to the past and what happened currently. It involve both of the time. Okay, finish for the hypothesis. Then we move to critical value. For this critical value, similar, we using table F. Okay, table F. And then we have the degree of freedom, df, sorry, equals to n minus 1. How many number here we have? We have 9. Up until 9, 9 minus 1 equals to 8. Okay. And then we have the alpha equals to 0.05. 0.05. This one tail, yeah, one tail, because this one is at the left. Okay, is smaller, then it will be on the left lah. This one T. What is the value? This one tail 0.05. Here 0.058. 0.05, 1.86. The T alpha 1.86. But this one on the negative side. That's why the alpha is negative 1.86. Please make sure you write it correctly, so that the examiner will not be confused lah, whether it's positive or negative. Sometimes you know how to do it, but when you write it wrongly, the examiner cannot give you marks. Okay, then it will be a waste lah. Okay, supposedly you get mark for that, then it a loss for you. Okay, and then we have this t value. When we look at this t value, some of the things inside the formula, some of the component inside the formula is quite unique, quite rare, that we doesn't know what is that. That's why we need to find it first. For example, this one. Okay, how to find this one? How to find this one? For this one is 0 lah. That means to insert the value inside the t test value, the t test here, you need to find this one and also this one. Of course, the n itself, you know about the n. N is 9, right? Okay, now we need to find D first. Okay, this D is summations of D dividing by N. How to find D? We need to minus x1 with x2. What is x1? X1 is the data for the past. Okay, 3 years ago. For the past is x1, but today is x2. You need to minus one by one using the calculator lah. I will not show lah ya. Takkan saya nak tunjuk juga. 11 tolak 82 tolak 69 negatif 5.27. Kamu boleh buat lah sampai habis kan. Benda mudah. Macam ni takkan saya nak tunjuk. Okay, up until then you need to sum up everything, add up everything for this part, because you want to find summations of D. And what is the summation of D? You can refer to page 510. Okay, negative 9.73. Okay, 9.73. And then you do for the second part, because in this standard deviation for the S, we have D square there. We have D square, then you need to square every D here. Okay, you need to square every D here, and then you need to sum up D square here, and the answer will be 40.54. Okay, 40.54. This one is very simple lah. Hopefully you can do lah. Please lah ya. Kamu jangan tengok saja video saya ni. Sambil-sambil tu buat lah. Okay. Sharpen your skill doing this mathematics. Okay. Sharpen your skill. Sharpen your time. Okay. Doing this mathematics lah. Mathematical works ni. And then we move this one first. We have how much? Negative 9.73 divided by 9. The answer will be negative 1.81. And then we insert the value for this one. We have n 9. Summation of D square 40.54. And then we minus with summations of D, negative 9.73 square, divide by 9 times 9 minus 1, 8. Okay, and then we try to use calculator. What is it above? 9 times 44. 4 minus inside the bracket minus 9.73 and close the bracket square. At the denominator we have 9 times 8. The answer will be 1.937. Be careful ya when using calculator. Please make sure the number you press appear on the screen. Kadang-kadang bila kita tekan nombor tu tak appear, and then we are confidently answer that. Okay, fill up on our formula. Then it's a wrong thing lah to do. It's a waste, another losing marks. Please make sure that you doing it correctly. Then we have the formula here. And then what is the negative 1.081 minus 0 here, and then dividing by the 1.937 square root 9. Okay, and then we have fraction here. negative 1.081. At the bottom, we have fraction 1.937, and then at denominator square root n 9, okay, equals to negative 1.674. Where is the location? Here, 674. We have negative 1.86. It fall at non-critical region. We fail to reject null hypothesis. That means 3 years ago and today are not different. They are equal. Okay, they are equal. Deposit in the bank today is not greater, okay, today from the past is similar. That's how you do for 9.6. This one try to do by yourself, yeah. 9.7, and this one also lah. That is the formula for confidence interval. Just insert the value sahaja dalam formula tu. Okay, now I will show to you about the proportion. Okay, for this part, I will go directly to the example, because from the example we can clearly see that this is a different statistical analysis compared to the previous. Okay, it easily we can differentiate, discriminate what type of statistical analysis that we can use, so that it can give us the answer whether these two group is similar or different. Okay, I read first on the example. In the nursing home study mentioned in the chapter opening statistics today, the researcher found that 12 out of 34 small nursing home had resident vaccination rate of less than 80%, while 17 out of 24 large nursing home had vaccination rate less than 80%. At alpha equals to 0.05, test the claim that there is no difference in proportion of small and large nursing home. Okay, here we have the proportion. Here we have small and large that we need to differentiate. We need to find the significant difference, whether it's significantly different or not. Clearly we can see that they have a two proportion here. Okay, two proportion. First we have the small nursing home, and second one we have the large nursing home. Okay, before we going through step 1 up until step 5, we extract out first the information. Okay, this one is for the sample, of course. We have the n1 equals to 34, x1 equals to 12. It's better for us to write x1 first, and then we have x2, we have 17, and 2 we have 24. Okay, and then we have the probability of sample, proportion of the sample is equal to x1, n1 equal to 12 over 34. And then we have the P2, because they have two proportion of sample here, x2 and 2 equals to 17 over 24. We finish about that. And then if we look at this, okay, look at this here, something that's quite unusual for us. This one we can understand because this is the proportion for population. However, in the question, in the example, there is no information about the proportion. That's why we need to find the proportion, weighted estimate proportion for the population. That's why P here, P line here, is the weighted estimate. It quite similar to proportion here, but difference. Okay, but different. Here will be 0, here they have a value, they have a formula that can we find the P line there, equals to x1 plus x2 divided by n1 plus n2. Then we can get the value x1 is 12 plus 17 divided by 17 and 34 plus 24. Then here we get 29 over 58. Okay, and then we do for the step 1 first, hypothesis. How to write the hypothesis? Because here we have the proportion, then we write P1 equals to P2. For the alternative hypothesis, you need to find the word less or greater. If there is no indication of less and greater inside the equation, it means it's not equal. Okay, it's not equal. P1 is not equal than P2. That means this one is 2 tail. If this one is 2 tail, we have a graph here. What we need to do, we need to divide the alpha. Alpha equals to 0.05 here, and then alpha divided by 2, this one will divide by 2, 0.025. We need to find the z-score for the alpha. Okay, and then this one I repeat again many times for you. This one is the non-critical region. This one is critical region. If the value falls on the non-critical region, we fail to reject. H null. If it falls on this, then enough evidence to reject null hypothesis. We need to find the critical value. I will not show you how to find the critical value. You need to minus first with a 1. Okay, minus, and then you got 9.75, and the critical value will be negative 1.96. We have done this many times. Previously, we are going through this one. Similarly, negative 1.96 for the critical value. Then we go to the step 3, test value. Then we insert all the value for the test value. Okay, minus 17 over 24 divided by, and then we 0.5. Okay, ini this one is 1 over 2 0.5. How to find the Q? 1 minus the equal to 0.5 times 0.5 times inside the bracket 1 over n1 34 plus n2 24. Then using the calculator lah. Okay, using the calculator. Okay, we have the fraction here, and then we put another fraction, 12 over 34, and then we minus. Please make sure you push it correctly. Sometimes I myself doing it wrongly. Okay, jadi please make sure you do not mistakenly insert the wrong value there. No. Okay, 0.5. No, also 0.5 times 0.5 times inside the bracket we have a fraction 1 over 34 plus 1 over 24, sorry, we close the bracket and we got negative 2.66. Of course the answer will be different from the textbook, because textbooks they calculate first one by one. First they minus this one first, and then they round it off. When they round it off, they lost certain value for the decimal. When they lost certain value of the decimal, it become larger compared to the one I use, because the one I use they include as much as possible the decimal value. Okay, for example, this one, if you look at the calculator here, they have a value of negative 2.660538515. They're including that. But for the textbook, they're not including all that decimal value at the back. They round it off. That's why the value much larger compared to what I get when I using calculator. Okay, nonetheless, we put the value for the test value here, then the value located at this. Okay, I enlarge it. Located at these places, negative 2.66. That means it falls on the critical region. When it falls on the critical region, we have enough evidence to reject null hypothesis. That means the large nursing home and small nursing home is different. Okay, is different. Okay, that's how you do for the two proportion. Hopefully you can do by yourself for 9.10 here, and also 9.11, the confidence interval. Just insert the value. Okay, when you insert the value, then you will get the answer. What interval from smaller interval to the larger intervals. Now we move to another type of statistical analysis. It involves the chi-square, or in the question itself, it give you the data about the variance or the standard deviation. Then you directly know what type of statistical analysis you will do. But please bear in mind, for the two variance, two mean, two proportion, they're different from the hypothesis testing before this. Okay, before this you do the hypothesis testing, is basically based on one population saja, but one mean saja, and then you try to test whether the current information is significantly different or not from the whole lots of population mean. But this one you have two. Okay, you have two type to see that whether it's different or not. Okay. And of course, among the very important part in fulfilling all the step here, state hypothesis, find critical value, compute, make a decision, summarize result, to find the critical value. Because in this part you need to use table H. Table H itself consists of many things. Okay, because of the alpha itself is giving you different table. If you look at here, we have 0.025. This is one table only for alpha 0.025. If the alpha is 0.05, one table you need to use for finding the critical value. Okay. Okay, we try to do 9.12. 9.12, you can also look at page 530. Okay, 530. 530, example 9.12. Find the critical value, right tail F test 0.05. The degree of freedom for the numerator are 15, denominator 25. This one is very easy because it already give you the denominator and numerator. Just use the table using the alpha value, then you get the critical value. How to do it? Then we look at the table. Alpha 0.05. Alpha 0.05 here. Okay. And then DFN. Here we have the DFN, degree of freedom numerator. And here we have the DFD, degree of freedom denominator. We have 15 and 25. Okay, 15 and 25. 15, of course we have the 15, but if you look at this, we have 13 and 14. If you come about the degree of freedom for numerator is 14, you choose the smaller one, you choose 12. This one you can read in the page 531. They have an explanation about that using the smaller value. Okay, if they are between 12 to 15, using the smaller value, that is 12 lah. Okay, if you are 11 degree of freedom numerator, then you choose 10. That's how you choose. And then we have 21. Here we have the 21. And then you try to align itself so that we have 2.818. Okay, we have 2.18. Okay, this one you try to do by yourself. I want to explain about 9.14. Okay, 9.14 in the page of 532. A medical researcher wish to see whether the variant of the heart of smoker is different from the variant of heart rate. You see, here they give you variant and also the variant. For proportion, they give you proportion. For the t-test and z-test, they give you mean. How to differentiate mean and t-test or z-test? Number of sample. If number of sample below than 30, you know it's a t-test. Higher than 30 is a z-test. If the variant, you use the chi-square. Two samples are selected. The data are shown. Using alpha 0.05, is there enough evidence to support the claim? Assume the variable is normally distributed. We have two variants here. Okay, how to choose the denominator and numerator? This one also you can go directly to page 531. Okay, 531 they explain to you what number should be used as numerator, what value should be used as denominator. As a conclusion from that, what you need to understand, the larger variant should be numerator. Okay, larger variant should be numerator, while the smaller variant will be denominator. Okay, larger variant will be numerator, smaller variant will be denominator. That means here we have number of n for numerator. This one is larger, right? 36. N is 26. Denominator is 18. Okay. Now we go to do for the step 1. What is the hypothesis? It's too large. Okay. Variant 1 equals to variant 2. Variant 1 not equals to variant 2. We have the tail here. Okay, the two tail, sorry, the two tail. The alpha is what? 0.05. The alpha is 0.05. Then we need to divide by 2. 0.025. Here we have 0.025. Here we have 0.025. What to use here? Then we go to the table. Sorry, we need to understand the degree of freedom first. DFD equals to 18 minus 1, 17. DFN equals to 26 minus 1 equals to 25. Okay, now you use 0.025. we have here 0.025. DFD is 17. Okay, we did not have 17, then we choose 15. DFN, sorry, terbalik lah ya. Ni sini adalah DFN 17. DFN 25. Okay, we have 24 here. And then DFD we have 17. Also have there. And then we try to line it. Then we get 2.57. Okay, 2.56. Here we have 2.56 for the chi-square right equals. Then we go to, okay, now we directly go to this one, S1 and S2. Just divide saja. S1 36 divided by 10 equals to 3.6. Which is the location of 3.6? Here is the location of 3.6. Then it falls on the critical region. When it falls on the critical region, we reject null hypothesis. Okay, we reject null hypothesis because we have enough evidence to reject null hypothesis. For the other part, you can do by yourself lah. We have other two type of example here. You try by yourself. Okay, that's all from me. Thank you.